Hello everyone, this is Vijay Lakshmi Sugnali and this is my YouTube channel WinMaths. Here, this YouTube channel helps to those which are studied second PUC NCERT syllabus. I solve the examples, problems and exercise problems based on the syllabus and topic wise with related theories. This video contains basically reduced syllabus of Karnataka PU Board 2025 and also some basic results of particular syllabus for Karnataka CET examination. Here in this session we discuss the main concept, that is minors and cofactor. From this chapter there is a one 4 marks questions and one 5 marks questions will be asked for annual examination. Here minors and cofactors are important concept, but there is no questions asked for minors and cofactors separately, but this is the basics which helps to solve the 4 marks and 5 marks questions. Here the mainly minors. Okay, minors means for considering any determinant of order 3. Okay, here I considering the determinant a is equals to, that is generally determinant containing the elements a11, a12, a13. Here a21, 22, 23, 31, 32, 33. These are the elements. Okay, a11, a12, a13 up to a33. These are the elements of the determinants which are present on that I in the form of ij. I means ith row, j column. Here also representing first a11 means first row, first column. The element represent first row, first column. Here there is a minor of the first element. Here for this one we have to calculate minor for each element. Each element carries its own minor as well as cofactor. Minor means for any element of a1. Okay, for any element of a1, for this one minor is the neglecting that the element which is lies on the first column, first row. That's why neglect first column, first row, then multiply or calculate the determinant value, that is the value of the minor. Okay, usually minor can be written in a capital letter. Okay, now for the first element, here the first element is a1. Minor of the first element is, that is m11 is the determinant of deleting the column and row which is lies in that element, that is a22, a23, a32, a33. Similarly for any element of this determinant is, so I have considered a22 now. Here for this element we have to neglect the element which is present in that row and that column, have to neglect it. For the a22 I have neglect, for this element I have neglect the whole row and column. The value becomes, the determinant value is, for neglecting second row, second column, the elements are a11, a13, a31 and 33. then finding the determinant value, the answer will be the minor of that element. Here minor of the first element is the determinant of this value, that is a22 a33 minus of a32 a23 cross multiplication, then subtract. Okay, minor of the first element is determinant of the given value or given determinant value regarding neglecting the number which is lies on the row as well as column. Okay, for this one the minor of the element 2 is determinant value of a11 a33 minus of a31 and a13. Here I solve one example that becomes easier to understand. Here I consider one example, that is a determinant of A containing the elements 1 3 4 7 8 2 and 4 3 5. Here I want minor of an element 1. I want minor of 1. Okay, here minor of 1 is the element 1 which is lies in first row first column. That's why I neglecting or I delete first row first column, then the determinant is 8 2 3 5. Okay, the value becomes 8 into 5, 8 5s are 40 minus 3 2s are 6, then answer will be 34. This is the value of the minor one. Minor of an element 1 is equals to 34. So have to find similarly for each element. Okay, here I consider the 2. Okay, now minor of 2, minor of 2, the element which is present in second row third column, it is represented as second row third column m23, that is minor of 2 is neglecting second row third column, that is neglecting second row third column. The elements are 1 3 4 3, 1 3 4 3. Okay, here the determinant value, that is 1 into 3, 3 4 3s are 12. Then the answer becomes minus 12 plus 3, that is minus 9. The minor of an element 2 is minus 9. Here check for all the elements of the minors. Okay, this is the method of finding the minors. Now then the concept is cofactor. Then there is a concept cofactor. Okay, cofactor means cofactor can be represented in capital letter A. Cofactor can be represented as a capital letter A, Aij, and minor can be written that is Mij. Here cofactor can be written in Aij, that is Aij is equals to cofactor of an element A is equals to minus 1 to the power I plus j into minor of ij. Okay, it means have to take minus 1 to the power I plus j. Here taking for the elements. Here we know that already. For the same example I have considered. Here there is a determinant of the elements 1, 3, 4, 7, 8, 2, 4, 3, 5. For this one we have to find the cofactor. Okay, aij minor of 1. Then now finding the cofactor of 1. Cofactor of 1, by the definition of cofactor, it can be written as minus 1 to the power. Here I plus j, the element 1 represent first row, first column. That means I represent row, j represent column. Here the first row, first column. Okay, into minor of m1, because we want the elements cofactor of an element a11, that is 1. Here minus 1, 1 plus 1 2, minus 1 square, it becomes plus 1. Minor of an first element 1 is 34. Therefore answer will be 34. Hence cofactor of 1 can be written as 34, or cofactor of 1 is 34. Similarly for 2, 3, that is the an element of 2, 3. Here we know that cofactor of 2, that is equals to minus 1 of 1 plus 1. Here the element 2 which is lies, the element 2 which is present in second row, third column, that is m23. Here cofactor of 2 is, that is a23. It can be written as a23. That is, here 2 means row plus column of m23, an element 2, 3. Then minus 1, 2 plus 3, 5. Minus 1 to the power 5 have to multiply minus 1 5 times. Then the answer becomes minus 1 m23, that is minus 9. Minus 9. Here minus into minus, it becomes 9. Therefore cofactor of the element 2 is 9. Okay, this is clear now. While taking the examples it will clear for you. Okay, now here there is one example. Find the minor of an element 6 in the determinant. They given a determinant containing the elements 1 2 3 4 5 6 7 8 9. Here for the element of 6, okay, we have to find the minor of an element 6, that is minor of 6 is the element which is present in second row, third columns. So that's why I neglect this column and this one. The elements are 1 2 7 8. Then the determinant value is 1 into 8 8, 7 into 2 minus 14. Therefore the answer becomes minus 6. 8 minus 14 or 14 minus 8, it becomes minus 6. And therefore the minor of 6 is minor of an element minor of an element 6 is minus 6. Then there is another one example, that is example 20. Here find the minors and cofactors of an element of the determinant. Here we have to find the minor and cofactor of each element. Here the first element I consider A1. Here second element, first row, second column, A12, then A21, then A22. These are the elements of the given determinants. Therefore, A11 is, the first element is 1, then minus 2, 4 and 3. These are the elements of the given determinant. Now finding the minors for this element. M11 is negating first row, first column, and that is minor is 3. Here for the second element neglecting that row column, then the minor of the second element is 4. Similarly for minor of 2 1, here for this element neglecting row column, the minor will be minus 2. Then M22, the minor of the second element which is lies in second column, second row, that is 3. For this element the minor will be 1. Now finding the cofactor. Cofactor usually denoted by Aij. Here for the element 1 1, that is minus 1 to the power 1 plus 1 into m1. Here 1 plus 1, 2, minus 1 into minus 1, it becomes plus 1. Okay, minus 1 square into m1, that is 3. Hence the answer is 3. Okay, the cofactor of an element A11 is 3. Similarly for element 2, A12 is minus 1 of 1 plus 2 into minor of an element minus 2. Here minus 1, 1 plus 1, 2, it becomes 3, minus 1 to the power 3 into the element 4. Here minus 1 to the power of 3 minus come minus 4. Here A21 minus 1 to the power 2 plus 1. Then M21, it becomes minus 1 to the power 3 into minus 2. Here is a minus 1 minus 2, it becomes plus 2. Then A22 minus 1 to the power 2 plus 2. Okay, then M22, that is 2 into plus 2, it becomes 4 minus 1 to the power 4, that is plus 1. 1 into here M22 is 1, then it becomes 1. Therefore minors and cofactors are of the determinants are solved here. Next there is a one note point, or there is a one remark point. Delta means determinant value. Determinant value. We can calculate determinant values by using the cofactor in 6 ways. Okay, that is delta value is expand. For taking example A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, then delta value It means determinant can be find because three columns are there and three rows in 6 ways. The value becomes the corresponding values of along with first row, that is R1 is A11 with the cofactor of A11 plus A12 corresponding covector, then the element of A13 corresponding cofactor of an element A13, their sum of their corresponding cofactors of a row 1 is the determinant value. Similarly, for the sum of the corresponding elements with the cofactor of an element is equals to delta y. It can be taken in 6 ways. It can be written along the column 1, that is delta is equals to, for this column, A11 A11 plus A21, the corresponding cofactor A21 plus A31 corresponding A31. This is the delta value, and this is also one of the important remark and note point. Here there is a exercise problems. Write minors and cofactors of an element. Here there is a one shortcut method. So you have to write the signs of the given determinant. Here there is a plus, minus, plus, plus, minus, here minus and plus. Easily the sign will be multiplied, then the value of the cofactors given. Here A11 is the first element 2, then minor of the element is, okay, that is 3, because neglecting row and column, then cofactor multiplied by the, here the symbol have to multiply, plus of m11, that is 3, okay, then A12, it becomes the element is -4, the corresponding minor is neglecting row column, that is 0, the corresponding cofactor is minus of, because the sign is 0, it is 0, then A21, the element 0, the corresponding minor is -4, and the element 21, the corresponding cofactor, here there is a minus and this one becomes +4, okay, the sign will be multiplied. Again, for the second element, minor of an element 3, that is m22 is 2, and the corresponding cofactor is +3, because the symbol multiplied by the 3, okay. Again, similarly for this I have written plus, minus, minus, plus. Now element A11 is A, the corresponding minor will be D, and cofactor is, here it is multiplied by plus symbol, that is D. Again, A12, the element C minor is B, okay, the corresponding me. Next, the multiplied by negative symbol, it becomes -B. Again, 2 1, the element B minor of an element is C multiplied by negative symbol A to 1 is minus C. Okay, again A to 2, the element D, the corresponding minor is A. Then the value of the cofactor is plus A. These are the minors and cofactors of the given determinant. Here also I check the okay. Now first I multiplied plus minus plus minus plus minus plus minus plus. Okay. This is helpful for finding the cofactors. Here there are the elements A11, A12, A13, 21, 22, 23, 31, 32 and 33. Okay. For these elements we have to find the minor and cofactors. Okay. Minors and cofactors. Now the first element A11 is 1. Here 0, 0. I consider 0, 1, 0, 0, 0, 1. Okay. Neglecting first row, first column, the minor of the element is 1 into 1, 1. For the second one, this element neglect the column row 0 into 1, 0, 0 into 0, 0 becomes 0. Then M13. Here the element is 0. 0 into 0, 0 into 1, it becomes 0. For the element 0, the minor. For this element, neglect this one, this 0 into 0. 0 into 1, 0. M22. Neglect row column. 1 into 1, it becomes 1. For the corresponding elements of 2, 3. Here also 0. M31. This is also 0 because the elements of containing zeros. Here for this one M32. For this element neglecting this row column 1 into 0, it becomes 0. For the last element, the minor of this element is, it becomes 1. Now multiply the corresponding elements, we get cofactor. A11 multiplied by plus sign 1 because the first symbol containing positive. Here A12, here minus, it becomes 0. There is no elements multiplied here. 1, 3, it becomes 0. Then A21, it is also 0. Now check the minor of an element. Here the element 2 which is present in second row second column, the symbol is 1. Again for this one, cofactor of 2 3 is 0, cofactor of 3 1 is 0, cofactor of 3 2 is also 0, and cofactor of 3 3, the corresponding sign will be plus, hence the value is 1. Therefore these are the minors and cofactors of the given determinant. Here there is a second question. Here there is a question number 2. In this question also we have to find the minor and cofactor of the given determinant. Here the first element, that is a11 is equals to 1, the first row first column, then the first row second column the element is 0, then the first row third column element 4, the second row first column the element 3, and the element 2 to 5, then the element 2 3, that is -1. Here for the minor is, while neglecting the row and column the element which is lies. Okay, here the determinant is 5 minus 1 1 2. Again for m12 the element 0, neglect this row column, that is 3 minus 1 0 2. Then m13, here the determinant is 3 5 0 1. Again m21, for the element 3 the minor is 0 4 1 2. Again m22, the minor is 1 4 0 2. m23, the minor of the determinant is 1 0 0 1. Here for this element we have to check the minor. 5 into 2 10, 1 into 1 1 into minus 1, here is a 1 minus, that is minus into minus plus 1, that is 11. Again for this 3 into 2 6, 0 into minus 1 minus 0, that is 6. Again m13, the my 3 into 1 3, 0 into 5 0, it becomes 3, 0 into 2 0, 1 into 1 minus 1, then 1 into 2 minus 0, it becomes 1 into 2, here 2, the value is 2. Again here 1 into 1 minus 0, it becomes 1. Then next cofactor of an element 1. Here the element 1, the minor of an element 1 is 11. Cofactor, for checking the cofactor we have to multiply the sign here. Okay, here plus minus plus minus plus minus plus minus plus. Okay, for the first element, okay, there is a positive sign, multiplied by 11 we get plus 11, there is a cofactor. Here 6, the element of 0, for the 0 there is a sign is a12 becomes plus 6. Here minus minus into 6, that is minus 6. For the element 4 carries positive charge, then here the cofactor is 3. So better we have to write the sign, that is a21 is equals to minus 1 of minus 1, it becomes 1 because the sign of the element 3 is minus. Here a22 is plus 1, Okay, here 2, that is 2. The sign will be positive, that's why I am taking positive one. Here A23, it becomes -1 into 1, that is -1. Therefore, cofactor of an element -1 is -1. Cofactor of an element 5 is 2. Cofactor of an element 3 is 1. Again 4 is 3. Okay. Now, the question number 3. Using the cofactor of an second row, evaluate delta by using the second row. Okay, we have to use the second row here. Now, consider using the cofactors of an element second row. Here we have to consider only the cofactors of the second row. We already know the formula. Okay, delta is equals to, because I expand by using the cofactor and element, delta is equals to, for second row the element is 2 1 into cofactor of 2 1 plus a22 into cofactor of an element 2 plus a23 and cofactor of 2 3. This is the general formula for row. Okay, for second row, here we have to find the element 2 1 and their cofactor. Here the element 2 1 is 2. Again the element 2 2 is 0 and the element 2 3 is 1. For these elements we have to find the minor of 1 1. Here 2 1. So we have to neglect the first row, second row, first column. The matrices containing the elements 3 8 2 3. Okay, then the minor is 3 into 3 9 minus 2 into 8 16. Therefore minus 7. Okay, again m22. For the element 0, I have to neglect the row and column which is lies on the element 0. That is 5 3 5 8 1 3. That is 5 3s are 15 minus 8. It becomes 7. Okay. Next, m23. Here the element is 1. For the determinant 5 3 1 2. 5 2s are 10 minus 3 is equals to 7. Okay, these are the cofactors. Okay, these are the cofactors of an element. Now, cofactors, that is A21 is, here there is a symbol. Okay, I have considered the symbol, that is here plus minus plus minus plus minus plus minus plus. Okay, for this the element 2 carries negative sign, that is negative. Then the cofactor of A22 is, then cofactor of A23. It carries negative sign, it carries positive and negative. So we have to multiply the elements by these values. Minus into minus 7, it becomes plus 7. 7 plus 7 into 7, it becomes 7. Minus 7 into 7, it becomes minus 7. Therefore, we get the values. Again, substitute the values here. Here, substitute the values. Delta is equals to A21. A21, the element 2, 2, cofactor 2, 2, and element 2, 3, cofactor 2, 3. Okay. Then substitute values here. Okay. Then A21 is 2 into 7 plus 0 into 7 plus here 1 into minus 7. That becomes 2 into 7 14. Here 0. 1 into minus 7 minus 7. 14 minus 7. Therefore, the delta value becomes 7. Here the delta value is 7. Then the next question number 4. Okay. Here the question number 4, using the cofactors of an element of third column, you have to evaluate the delta. Okay. They give a third column. Here there is a third column. Okay. By using the third column, we know the delta by using the third column. The element 1 3, okay, into cofactor of 1 3 plus A23 cofactor of A23 plus cofactor of A33 into cofactor of A33. Okay. Now again substitute these values here. First the element A13. Here the element A13 is YZ and element A23 is ZX and an element A33 is XY. Okay, we have to find the minor for this element, so have to neglect it. The determinant is 1Y 1Z. Here for this, neglecting this row, column 1x 1z. Again M33, that is xy. Okay, here neglect this and this, we get 1x 1y. Okay, then the values of the minus are 1 into z, z minus y, here z minus x, and 1 into y, 1 into x minus x. This is the minor. Okay, now we have to multiply the sign for the cofactor. Here plus minus plus, minus plus minus, plus minus plus. Okay, for the first element A2 A13 is equals to cofactor of A23 and A33. Okay, the symbol, the element carries the symbol positive. Here there is a negative and positive. Okay, then we have to multiply the minor, that is z minus y, z minus x, and y minus x. This is the cofactors of the 1 3 element and cofactors of second row third column, as well as cofactor of an element xy is y minus x. Here we have to find the delta. Delta is equals to A13 cofactor 1 3 plus A23 cofactor a23, again a33, a33. Okay, now substitute. Here a13, the value is yz, into a13, that is z minus y, plus a23, that is zx, into the cofactor 23 is minus, I multiplied minus on this element, it becomes x minus z, plus, because minus into z, minus, minus into minus, plus, I taken it as x minus z. Then here xy, then y minus x. Okay, then we have to multiply here. First y into z, z square, minus y square z, plus z x square, minus z square x, plus xy square, minus y x square. Okay, now anything will be get changes. Okay, there is no changes here. This is the final answer. Okay, this is the final answer. Otherwise you can simplify in 2-3 steps, but this much is enough. Okay, now there is a last one question, that is multiple choice questions. Here they given delta and aij is a cofactor of an element aij, then the value of delta is given, you have to find the value of delta. Here we compare the values while checking. Here the element a11 with cofactor a31, this is not possible because the element with same cofactor of an element. Okay, here both are different. Now checking the second. Here a11 with cofactor. Okay, the element with corresponding cofactor. Here the element with no corresponding. Here a12 element is there, the corresponding is 1 2, but they given 1 2 1, that's why this is also not. Here the option is wrong because the element is 2 1, the corresponding of cofactor 1 1 they given, it is wrong. Now check here, the element a11 with corresponding cofactor is correct. Here also the element with corresponding cofactor, yes, the element with corresponding cofactor, therefore we say that the sum of an element with corresponding four factors, therefore the option C is correct. Up to this much the minor and cofactor concept will be completed. In a section we have to find, or we have to discuss the inverse and adjoint of the determinant. Okay, thank you.